Okay, one more thing that I want to mention before I get into the actual conversions is temperature. Does anybody know the temperature at which water boils? And if you're used to the degrees Fahrenheit, the imperial system, then degrees Fahrenheit, the water boils at 212 degrees Fahrenheit. However, if you're talking about water boiling at on the metric scale, it's a nice round 100. Again, a nice 100. 212 for water boiling? Where'd that come from? Now, this does assume pure water at 1 atmosphere of pressure, because if you change the pressure on water and you change what's in the water, the temperature it boils at will change. What about freezing? Freezing in the degrees Fahrenheit is at 32 degrees Fahrenheit. At the metric system, it's 0 centigrade. Again, based on science, not some arbitrary numbers you have to memorize. Human body temperature, well, this one happens to be an interesting, well, it should be further down. It should be down, whatever. 37 is, and 98.6. Once again, just by luck on this case, but 37, it's a nice round number instead of 0.6. Now I'll draw the little lines to show a break, because there's no way 37 is closer to 100 than 0. So these little slice lines through show a break in the scale. So normally when we do conversions, everything starts at 0. So if I have 0 pounds of gold, which I have right here, 0 pounds of solid gold right here in my hand. What does that mean? I got nothing. In this hand, I have 0 kilograms of solid gold. I got nothing. 0 means nothing. 0. If you don't pay attention, you might miss this, but there, I went on a 0-mile run. Did you see it? Oh, there it was again. I went on a 0-kilometer run. Damn, I'm fast. 0 means nothing, right? I didn't go anywhere. I don't have any gold. I didn't go on a run. 0 means nothing. 0 means zilch. And that is true with most measurements, whether we're talking about volume, if we're talking about area, if we're talking about length or distance, if we're talking about mass or weight, if we're talking about any of those other measures, 0 means nothing. But temperature, 0 doesn't mean nothing. In centigrade, 0 means the freezing point of water, pure water at 1 atmosphere of pressure. In 0 degrees Fahrenheit, it's time for Canadians to put on a sweater. For Americans, we're freezing our asses off. 0 is just really cold. It is 32 degrees below the freezing point of water. Because zeros are defined differently, we have to do something a little differently in our math in order to convert for temperature. And we'll get into that when I go over the examples. But remember that if you're going to put something in your notes about this, why do we use a conversion equation for temperature conversions? Because the zeros are defined differently. Remember that. We use a temperature conversion equation because 0 is defined differently between centigrade and Fahrenheit. Okay, so let's go back to that document that is on Canvas, the first thing you get. And the first thing about the metric system here is the basic units and the symbols. And you'll notice that capitalization counts. Meters, a measure of length. Kilograms, a measure of mass or grams. Metric tons for measuring large things. That's equal to 1,000 kilograms. Seconds are recognized as metric. Kelvin is another temperature measure that's only used in science for very, very, very cold or very, very hot things in most cases. The average person deals with centigrade or degrees Celsius. It depends, Celsius. I tend to use centigrade, but a lot of people use Celsius. You can go either way. And the ones that aren't in bold are the ones that we don't use too much. The only times I've run across square meters is in non-US office space. Say you're trying to rent an office space or warehouse in Canada or Mexico, they'll talk about square meters of footage, of area, excuse me. Hectares is area used for larger pieces of measurement. So it's the equivalent to our acres. They're bigger than our acres. And you might notice here, a hectare is equal to 10,000 square meters. They're the same thing. 10,000 square meters is a hectare. And that's a lot of area. That would be one heck of a big warehouse. Volume could be cubic meters. I didn't bold that one because we don't use that too much. We generally use liters. Now, cubic meters can come in handy for large volumes. So if you're talking about the airspace inside of a large warehouse, you're talking about HVAC systems and the movement of air in a large commercial building, they might talk about cubic meters of air movement. It's just more convenient than liters. And the rest of these are more for engineering and physics, newtons, joules, watts, pascals, hertz. And there's more. That's not the entire list, but that's a pretty darn good list. And then we put a prefix in front of those numbers in order to give it magnitude. So a meter, the very first thing was meter, a small m, right? And if I want a 1/100th of a meter, what do I use? Centimeters. Centi means 1/100th, or 0.01, or 10 to the negative 2. That's the same as saying 1/100th. 10 to the negative 2 is the same as 1 over 10 squared is 1/100th. So I get something like centimeter, 1/100th of a meter, or millimeter, 1/1000th of a meter, or megameter, capital M. Again, very important. Capitalization makes huge importance in the metrics, and mega, capital M, is 10 to the 6th, or a million of something, a million meters. That's a long way to run. That's 1,000 kilometers, 1,000 thousands, right? A million. And this goes all the way from iota, 10 to the 24th, 1 with 24 zeros. And down the list, zeta, exa, peta, things that you maybe never heard of. Maybe you've heard of peta because of computers, and we hear a report on Google and how many petabytes of data Google stores every day. Tera, you should definitely have heard of that. Terabytes are standard with computer hard drives these days, a terabyte drive. gigabytes and megabytes. Your cell phone usage, you deal with how many gigabytes of data do I have? How many billion bytes of data do I have? Mega is 1,000,000, kilo is 1,000, etc. So the ones in bold are the ones we tend to deal with more commonly. The ones in gray here, we really don't use much at all, with the one exception of centi, which we use in one situation only that I know of. Centimeters. When we're talking about measurements, we do use centimeters for using small measurements with a ruler. I'm sure you dealt with centimeters in grade school and in high school. But other than centimeters, I've never used centi ever on anything else. Never centiliters, never centigrams. It's only centimeters. That's the only time I've ever used it. Hecto, deca, and deci. The only times I've ever used those in my life is on a metric exam in a class. We don't use them. They're not that practical. On the smaller side, milli, 1/1000th, micro, 1/1,000,000th, nano, 1/1,000,000,000th, and we talk about nanotechnology, right? So nano, I'm sure you've all heard of nanotechnology, but pico is becoming more common, just like peta on the large scale. Pico on the very, very small scale is becoming more common because we can measure picogram quantities of substances in irrigation water or toxins or things in the air that we breathe. All of them have a letter of the alphabet except for micro. And micro is the mu symbol, the Greek mu, which kind of looks like the letter U with an extra tail on the lower left-hand side. So that's mu. And it has evolved over the years, but I generally write mu like that so I can recognize it in my lab book very easily with an exaggerated tail. If I look at my lab books, I often wrote milliliters like this. What did I do wrong? That's a lowercase l. Milliliters, capital L to be accurate. So I've got a lot of old lab books that are written this way. That's technically wrong. Now, would I know what I was talking about in my lab books when I'm mixing chemicals? Of course I would. So I was casual about it in some situations, but you really got to be careful about capitalization. Now, if I don't have any prefix, it's just meters. No milli, no mega, no kilo, just meters with nothing in front of it. Just the M. That's 10 to the 1 or 1. Or excuse me, 10 to the 0 power. I'm sorry. 10 to the 0 power or just 1. Any number to the 0 power equals 1. Go bug your math teacher if you want to know why. Doesn't matter. Any number to the 0 power equals 1. And 10 to the 0 equals 1. So to be consistent, we just write it as 10 to the 0. And that'll come in handy with one of the conversions we're going to do in a little bit. And how big is this? 24 power, 10 to the 24 power to 10 to the negative 24 power. That is a range of 48 powers of 10. One with 48 zeros. And is that big? I don't know. Is that big or not? And yeah, that's big. There's a video, the powers of 10 video, that only goes through 40 powers of 10. And with 40 powers of 10, it goes across most of the known universe. And in terms of meters, the number of meters in 40 powers of 10 is enough meters to go across the known universe and all the way down to inside an atom. So when you watch that video, you will appreciate it. If I were to go for a walk across the universe, and I took 10 to the 48 power steps, I would walk across the universe and back and back and back. I could walk across the known universe, I don't even know how many times, with 48 powers of 10 numbers of steps. It's a massive number. And there's another number that you maybe know that's even bigger, and you don't even know you know the number. A Google. What the hell is a Google? It's a search engine. Well, yeah, but where did the number come from? A Google is one with 100 zeros after it. That's what a Google actually is. And somebody thought, well, that's really cool. One with 100 zeros after it. I'm going to name a company after that. And they did. And you could take walks across the universe hundreds of trillions of times for hundreds of trillions of years and not reach a Google steps. Anyway, enough on those numbers. What else is in here? Here's a very, very simplistic basic conversion table. And this is something that I made up that is really grossly rounded off. I made the numbers easy for math-phobic people to do the math without having to worry about these long numbers. A lot of these conversion factors go on many places depending on how accurate you need to be. And most of the times going out 5 or 6 places is plenty. 3 is not usually enough. And in this case is 3 in inches, centimeters to inches. I only use 2 places, 0.39. It's only 2 decimal places worth of accuracy. So some of the numbers that you might get in the practice problems in this class might be a little bit approximate, and there could be some rounding error. But don't worry about that. Don't worry about that at all. I've given you these approximate numbers just to keep it simple and to go through the process without getting stressed out about numbers. So for example, if I were to say 1 foot in meters. Now that's giving me 4 decimal places. And actually it's even more than that. Google also rounds off quite a bit. So 1 foot, 3, that's also 4 places. Anyway. Not going to worry about the accuracy of the numbers. But that is something that's important. Depending on how accurate your number needs to be, you need a conversion factor, a conversion number that achieves the accuracy you need for the job you're trying to do. If I'm doing everything in metric, I don't have to worry about that. But if I have to go back and forth between metric and imperial, I have to worry about that a lot. So note, most conversions are simply multiplying by 1. I'll show you some examples, and then you adjust the units. That's it. Just pay attention to the units and multiply by 1. What does that mean? If 1 inch equals 25.4 millimeters, then 1 inch divided by 25.4 millimeters equals 1. If I divide things the same, they just equal 1. Such as 10 over 10 equals 1, right? What about 25.3 divided by 25.3? It doesn't matter. If whatever's in the top and whatever's in the bottom are the same, they just equal 1. And if I tell you that 1 centimeter is the same, or excuse me, 1 inch rather, if 1 inch is the same as 25.4 millimeters, they are equal, they are the same. If I have 25 0.4 millimeters over 1 inch, it equals 1. And if I have 1 inch over 25.4 millimeters, it also equals 1. It doesn't matter which is in the top and which is in the bottom. They always equal 1. All right? And we will put that to good use in a moment. But you have to be careful with the units because it's all about paying attention to the units. This only works if the different units share the same meaning for 0. Therefore, temperature needs something called a conversion equation rather than a conversion factor. Conversion factors, the factors are just multiplying by 1, some special form of 1. Conversion equation, we have to use it for temperature because the definition of 0 is different between centigrade and Fahrenheit. Be aware that certain non-metric units may have even more variations. So there's a US gallon versus an imperial gallon. Well, okay, fine. That means there's 2 different kinds of gallons, not just 1 gallon. If I'm using the US version, we changed it a bit. We're not using the same gallon that they used to use in England, Great Britain. They had what they called a gallon, and we made a new gallon. They're close, but they're not the same. And there's even a liquid version versus a dry version. So if I've got in the US, I've got a US liquid quart and a US dry quart. And in the old-fashioned England, Great Britain, there was an imperial liquid quart and an imperial dry quart. 4 different slight variations on what the hell a quart even means. And in the metric system, you got liters, and that's it. There is a liter, period. There's no liquid, there's no dry, there's no, well, Australia's version of a liter is a little different than Great Britain's version of a liter. No. And even England, the imperial originators, the ones that we inherited it from, they ditched that imperial crap a long time ago. They're metric. We're the only ones who have not made it to the modern world. We're the only ones living in antiquity with some very minor, trivial exceptions that are not economic, developed countries of the world. We're it. We're the lone holdout for stupidity. Are you surprised? I'm not. There's also a short ton versus a long ton. There's a calorie with a capital C versus a calorie with a small case c. And a kilocalorie, 1,000 of the small case c calories are equal to 1 of the capital C calories. I promise not to ask you that on a test, but calories can get confusing. A calorie with a capital C is actually the one we use for nutrition. It's actually 1,000 of the calories with a lowercase. So if you're on a 2,000 calorie a day diet, well, it's actually 2,000 times 1,000 calories in terms of the scientific measure of calories. 1 nutritional calorie equals 1,000 scientific calories. Anyway, you got to know what you're dealing with. And then there's some practice problems. And I'm going to go over some of these practice problems, but not just yet. I'm going to take a break and we'll come back and we'll deal with 3 different kinds of conversions: the conversion factor, the conversion equation, and the order of magnitude, as I call it. And we'll do all 3 of those when I come back.